In problem 1, we want to graph f of x equals x minus 8 over 1 minus x. So the first thing we're going to find is the domain. And to find the domain, we want to take a look at the denominator and figure out what we cannot plug in, which will make the denominator go to 0. And that number is 1. So our domain is negative infinity to 1, and then 1 to infinity. To find the y-intercept, we plug in 0. So if we plug in 0, we get negative 8 divided by 1. So our y-intercept is going to be at 0, negative 8. To find the x-intercept, we set the numerator equal to 0. So our x-intercept will be a positive 8. To find the vertical asymptote, we set the denominator equal to 0. So our vertical asymptote will be x equals 1. And since the degrees are the same, we do the leading coefficient divided by the leading coefficient, which would be a 1 divided by a negative 1. So that horizontal asymptote will be a negative 1. So before I figure out the range, I'm going to graph what I have first, and then we'll do the range later. So I have a y-intercept at negative 8, and an x-intercept at positive 8, and a horizontal asymptote at, a vertical asymptote at 1, and a horizontal asymptote at negative 1. So I'm going to put my y-intercept down at negative 8, and my x-intercept at positive 8. So it looks like my graph will form these two parabolas, right here and right here. If you can't see that, you can always plug in some additional points to get the rest of the graph. So now we know that our range goes from negative infinity to the horizontal asymptote, negative 1, and then negative 1 to infinity. For number 2, I'm going to first factor the denominator. So I get 2 over x. Looks like we'll have x minus 6 and then an x plus 3. So that will show me that the two numbers that will make the denominator go to 0 are negative 3 and 6. So my domain will be from negative infinity to negative 3, and then negative 3 to 6, and then 6 to infinity. To find the y-intercept, we plug in 0. So if I plug in 0 to the original function, I'm going to get 2 over negative 18, which is negative 1/9. And for the x-intercept, we set the numerator equal to 0. But if we did that, we would get 2 equals 0, and that doesn't make sense. So we do not have an x-intercept. Our vertical asymptotes, we set the denominator equal to 0. So we'll have two vertical asymptotes at x equals 6 and at x equals negative 3. For our horizontal asymptote, we want to notice the degrees. So the degree on top is smaller than the degree on the bottom. And whenever that happens, we'll always have a horizontal asymptote at y equals 0. So now I'm going to graph my function before I determine my range. So I have a vertical asymptote at negative 3 and at 6. So we'll put those on. Whoopsies. Okay, and then we have a y-intercept at negative 1/9. So pretty close to the x-axis. Alright, so now we need to plug in some additional points so we can see the shape of our graph. So I'm going to plug in something that looks kind of easy to plug in. Maybe a 2. So if I plug a 2 in, I get, well, let's plug 1. 1 might be easier. So if I plug in a 1, I'm going to get 2 over negative 5 times 4. So I get negative 2 over 20th, so negative 1/10. So that's like a little bit smaller than negative 1/9. So closer to 0. And then I'm going to plug in a negative value. So I'm going to plug in a negative 2 and see what I get. So if I plug in a negative 2, I'm going to get 2 over a negative 8 times 1, which is negative 1/4. So it's like a little bit lower down here. So it looks like what this graph is doing is it is rising up to make a sigmoidal, but just to check, let's plug in a number that is a little bit bigger, like maybe let's plug in 5. So if I plug in 5, I'm going to get 2 times negative 1 times an 8. Oh, and that's a negative 1/4 as well. So actually it looks like we have a parabola looking thing. So it looks like we have a parabola in the middle going like that. Alright, very flat parabola. Okay, so now on my sides, oh, I forgot to graph my horizontal asymptote at 0. And we only want to graph that horizontal asymptote on the sides. So now I am going to plug in a negative 4 and see what I get. So if I plug in a negative 4, I get 2 over a negative 10 times a negative 1. So that would be 2/10. So now I'm in the positive. So it looks like my graph over here will be a parabola going this way. And then I'm going to plug in a 7, so I know what my graph's doing on that side. So if I plug in a 7, I get 2 over 1 times 10, so I get 2/10 again. So it's symmetrical on that side. And here is our lovely graph. Alright, so now to do the range, we have that our graph goes from negative infinity up to 0, and then 0 again to infinity. For our next problem, I'm going to start out by factoring it. So I have an x minus 1 times an x minus 1 all over an x minus 3. So nothing ended up canceling, but that's okay. So we know that our domain is going to be from negative infinity to 3, and then 3 to infinity, because that is what we're not allowed to plug in. Our y-intercept is going to be a negative 1/3, plugging in 0 for y. We're going to have well, we'll have only one x-intercept because we want to set the numerator equal to 0. So our x-intercept will be at 1. And our vertical asymptote will be at x equals 3. And this time, we do not have a horizontal asymptote because the degree on top is bigger than the degree on the bottom. So instead of a horizontal, we have a slant, since the denominator did not cancel. So to find the slant asymptote, I'm going to do polynomial long division. And so first we want to ask ourselves, what do we have to multiply x by to get x squared? And that's an x. So that will give me x squared minus 3x. But then we want to change the signs, which gives me x. And then we can bring down the plus 1. So now we want to ask ourselves, what do I need to multiply x by to get x? And that is just a 1. And we're done. We have our equation of our line, which is y equals x plus 1. So that will be our slant asymptote. So now to start my graph, I am going to put on my y-intercept and my x-intercept. So So I have my x-intercept at 1, 0, and my y-intercept at -1/3. And then I'm going to put my vertical asymptote on at 3. And then I'm going to do my slant asymptote at y equals x plus 1. So we just graph that like the line y equals x plus 1. So we start at 1, the y-intercept, and we go up 1 over 1. So it'll just be this diagonal line. Okay, and now it looks like we're ready to graph. So we can connect our y-intercept and our x-intercept. And we don't want to go past the x-axis because we only have one x-intercept. So that's going to become the maximum value. And then we want to reflect our graph up in the upper corner. And that is our slant asymptote graph. For number 4, we want to first factor the denominator. So I have x plus 1 over x plus 1, x minus 1, and the x plus 1's cancel out, and I'm just left with 1 over x minus 1. So whenever a factor cancels out, that means that instead of having a vertical asymptote at whatever that x value would have been, which in this case it's -1, we have a whole at x equals -1. And since x minus 1 is still in the denominator, we'll have a vertical asymptote at x equals 1. So this will have a whole and a vertical asymptote. So that does affect the domain. We can't plug in a -1 or a +1. So our domain will be -infinity to -1, and then -1 to 1, and then 1 to infinity. To find the y-intercept, we want to plug in 0. So when we do that, we get a -1. And to find the x-intercept, we want to set the numerator equal to 0. So that will also be a -1. And our horizontal asymptote, since the degree on the bottom is bigger than the degree on the top, our horizontal asymptote will be y equals 0. So let's go ahead and graph this. So we have a y-intercept down at -1. And we have an x-intercept at -1. Oh, but we have a hole there. And that makes sense because we have a horizontal asymptote at y equals 0. So we can just kind of ignore that. We can't have an x-intercept if we have a horizontal asymptote there. All right, so now we have a vertical asymptote at +1. So it looks like our graph will go like this. And the whole just kind of got canceled out by that vertical asymptote, or by the horizontal asymptote. So we don't have to worry about it. This one's kind of tricky. So for the range, we get -infinity up to 0, and then 0 to infinity. For this next problem, we want to factor the numerator. So we get x minus 2 times x minus 3 all over x minus 2. And in this case, the x minus 2's cancel. So we know we're going to have a whole at x equals 2. And in this case, we're just left with x minus 3. So now x minus 3 is just a line if you graph it. So what we're going to end up with is the graph of a line, but with a hole at x equals 2. So since we have the graph of a line, we don't have any horizontal asymptotes or slant, because it's just the line y equals x minus 3. So the domain will be negative infinity to 2, and then 2 to infinity. To find the y-intercept, you just have to plug in 0, and we can plug 0 into x minus 3. So it'll just be a negative 3. And to find the x-intercept, we want to set the numerator equal to 0. So we'll just get an x-intercept of positive 3. So let's graph it before we figure out the range. So let's see, we'll have a y-intercept down at negative 3 and an x-intercept at positive 3. And then we just have the line y equals x minus 3, except in this line we have a hole at 2. So we want to make a hole there. And that'll end up being at 2 comma negative 1. You plugged a 2 into x minus 3, you get a negative 1. So that's where the hole is. So now when we talk about the range, our y values go from negative infinity, and then we don't have any y values at negative 1 because we have a hole there. And then we'll go from negative 1 up to positive infinity. For our last graph, we can't factor it at all. And if we take a look at the denominator, since we have x squared plus 1, there's nothing that we could plug in for x that will make the denominator go to 0, which means that our domain is negative infinity to infinity. To find the y-intercept, we just plug in 0 for x, so that will just be negative 5 over 1, so negative 5. And then to find the x-intercept, we have to set the the numerator equal to 0. So 3x squared minus 5 equals 0. So x squared will equal 5/3. So kind of funky, but x will equal plus or minus the square root of 5/3, which will be kind of a teeny tiny x-intercepts. But that's okay, we'll make do, we'll graph it. So since the denominator is never going to equal 0, we have no vertical asymptotes. But we do have a horizontal asymptote because the degrees are the same. So to find our horizontal asymptote, we do the leading coefficient over the leading coefficient, which is just 3 over 1, which equals 3. So let's go ahead and graph this guy. So I'm going to put my y-intercept down at negative 5. And then I'm going to put my x-intercepts on those weird x-intercepts, plus or minus the square root of 5/3. So that should be a little bit more than 1. So we'll just kind of guesstimate where that is. And then I have my my horizontal asymptote up at 3. So it looks like I kind of have this weird bell-shaped graph. So that means that the range is going to be bracket negative 5, because that's the lowest this thing goes, up to 3, and then it stops. For number 1, we need to sketch a graph of negative x squared minus 10x minus 23, and we want to label the vertex and the x and the y intercepts. So first, to find the vertex, I'm going to find the x value by doing x equals over 2a, which equals a positive 10 over 2 times negative 1. So I get a negative 5. Then I'm going to take negative 5 and plug it back in to find the y part of the vertex. So we get negative 5 squared, which is 25, but then we need to put the negative out in front, plus 50 minus 23. So we get 2. So we know that our vertex is at -5, 2. So I'm going to put that on my graph. Next, we want to find the y-intercept, and we do that by plugging 0 in, and that will give us -23. So I don't have a ton of space, so I'm going to put a -23 down here. And then I want to reflect that, so I'm going to go 5 away, and then put another point at -10, -23. So this graph is for sure going to cross the x-axis, but we want to know where. So to do that, we can either factor or we can complete the square. So first, I am going to try to see if it's factorable, but I don't think it will be since 23 is a prime number. So I'm first going to set this equal to 0. And then I'm going to add 23 to the other side. And I can't complete the square yet because of the negative in front of the x squared. So I'm going to multiply through by a negative. And then I'm going to complete the square. So we want to divide by 2 and square it, which will give us a 25 on each side. And then we want to factor. So we get x plus 5 squared equals 2. Then we want to take the square root. So we get x plus 5 equals plus or minus root 2. So x will equal -5 plus or minus root 2. So to put those on the graph, the square root of 2 is a little bit more than 1. So our first point will probably be at -3 point something, and then the next one will be at -6 point something. So we have a parabola looking like that. I didn't give myself too much room to do number 2, but number 2 is in vertex form, which means that we automatically know that the vertex is going to be 4, 3. So I'm going to go ahead and put that on my graph. And it's a good idea to kind of graph as you go. And now I'm going to find the y-intercept. And to do that, I'm going to plug 0 in for x. So I get 2 times 0 minus 4 squared plus 3, which is 2 times 16 plus 3, which will be 35. So I have a y-intercept way up here at 35. So I'm just going to cheat a little bit. And now I want to reflect that point, so I'm going to go 4 away in the other direction and put another point up at 35. And now I have a parabola. Oops, missed the vertex. There we go. Okay. And we can see that we have a vertex above the x-axis, and our parabola is opening up, so we will have no x-intercepts. So we don't have to find them. For number 3, we want to take an equation in quadratic form and write it in standard form, which also is the same as vertex form. So the first thing I'm going to do is take the 11 and subtract them to the other side. And I'm just going to turn an f of x into y so it's easier to write. And now we want to complete the square with 3x squared minus 12x. The only problem is we can't complete the square with the 3 out in front of the x. So I'm going to need to first factor that out. And now we're ready to complete the square with the x squared minus 4x. So I'm going to divide by 2 and square it. And 4 divided by 2 is 2, and 2 squared is 4. Which means I'm going to add a 4 into that side. But on the other side, since we need to balance the equation, I'm going to add in a 3 times 4, since that's what I really added to that side. So I'm going to add a plus 12. So that gives me that y plus 1 equals 3 times x minus 2 squared. And then to get it into vertex form or standard form, I'm going to subtract the 1. So I have 3 times x minus 2 squared minus 1. So my vertex is going to be positive 2 comma negative 1. And then to find the y-intercept, I'm going to plug in 0. So y equals 3 times a negative 2 squared minus 1, which will be 3 times 4 minus 1, which will be 11. So my y-intercept is at 0, comma 11. And to find my x-intercepts, I'm going to set this thing equal to 0. So I have 0 equals 3 times x minus 2 squared minus 1. So 1 equals 3 times x minus 2 squared. So divided by the 3, so we get 1/3 equals x minus 2 squared. And if I square root both sides, I get plus or minus the square root of 1/3 equals x minus 2. So x will equal 2 plus or minus the square root of 1/3. And I'm just going to rationalize the denominator. So x will equal 2 plus or minus root 3 over 3. And those would be my x-intercepts. And then our standard equation would go in for part A. For numbers 4, 5, and 6, we want to find the end behavior by looking at the leading coefficient and the degree. So for number 4, we have an odd degree and a positive leading coefficient. So I know that my arrows on the ends of my graph are going to start down and end up. So I just have to write that into words. So it's going to fall to the left and rise to the right. If you want to write this out with the symbols we learned in class, that's fine. It would be as x approaches infinity, f of x, I'm kind of doing it backwards. Let's do negative infinity first. F of x approaches negative infinity, and as x approaches positive infinity, f of x approaches positive infinity. For number 5, we have a odd degree, but it's negative, so we'll have the opposite end behavior where it starts up and ends down. So we could either write down that it rises left and falls right, or we can use our symbols. So as x approaches negative infinity, f of x approaches positive infinity, and as x approaches positive infinity, f of x approaches negative infinity. For our last one, we have an even degree with an with a negative leading coefficient. So both arrows will go down. So in symbols, as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches negative infinity. For number 7, we first want to factor out an x squared. And then we're left with x squared minus 4. And then we can factor that further to x plus 2x minus 2. So it looks like we get the x-intercepts. X equals negative 2. And x equals 2 one time. And then we'll get the x-intercept x equals 0 twice, because x squared, we could write that twice for x. So we would get the answer x equals 0 2 times. So we get x equals 0 with a multiplicity of 2. And then we just get x equals -2 and +2. And that just has a multiplicity of 1. For number 8, we want to factor by grouping. So first I'm going to see what I can factor out of my first two terms, x cubed minus 9x squared. So I can factor out an x squared, which leaves me with x minus 9. And then I can factor out a -4 out of the second two terms, which also gives me an x minus 9. So now when I put these together, I get x squared minus 4 times x minus 9. And I can take it one step further to factor. So I have x minus 2, x plus 2, and x minus 9. So I get 3 solutions here, and they all have a multiplicity of 1 since I only got them one time. So 2, -2, and 9. And they all have a multiplicity of 1. For our next problem, we first want to factor out a t. Then we have t to the 4th minus 6t squared plus 9. And then I want to factor more. So since I have a t to the 4th, I'm going to do a t squared minus 3, and then another t squared minus 3. And so then when I set each of those equal to 0 to solve, I'm going to get t equals 0, t equals plus or minus root 3, and then again t equals plus or minus root 3. So I got both plus or minus root 3 twice. So those both have a multiplicity of 2. So that one has a multiplicity of 2, and t equals 0 just has a multiplicity of 1. For number 10, we want to factor the polynomial, and we're given that x minus 2 is already a factor. So I'm going to use that hint to do synthetic division with 2, since I know that 2 is a 0. Since x minus 2 is the factor. So now I'm going to bring down the 3 and multiply and add and multiply and add and multiply. So I get 0 as a remainder, which is good. That means that x minus 2 is a factor and 2 is a 0. So now I'm going to use my remaining polynomial, which is 3x squared plus 8x minus 3, to factor further. So I'm going to factor it with a 3x and an x. And since I want to make it 8, I'm going to put a 3 over here to make a 9 and a 1. So I'll have a minus 1 and a positive 3. So that means that I have 2 other zeros at -3 and at positive 1/3. And I have a 0 at 2, which was already given to me. So all of these have a multiplicity of 1. So I'm just going to list them all out. And multiplicity of 1. For problems 11 and 12, we want to use the information we got from the previous problems that we did, and then graph our polynomial. So for 11, we found that our x-intercepts were x equals 0, and that had a mult of 2, so I'm just going to write times 2. And then we also got a 2 and a -2. To find the y-intercept, we just plug in 0, so we'll get 0 for our y-intercept. Our end behavior, since we have a even degree and it's positive, the two ends of our graph should end up. So now I think we have enough information to graph it. So I'm going to put my x-intercepts on at -2, 0, and 2. And I know that my graph must end up. So now I'm just going to connect all of my x-intercepts. I'm going to go through -2, and then I'm going to turn around. And since 0 has a multiplicity of 2, I'm going to touch that and form a parabola at it. So it should touch it and come right back down. Then I'm going to come down and then up through +2, and then back up. For number 12, we already found our x-intercepts, and those were 2, -3, and 1/3. So we don't have any multiplicities there. To find the y-intercept, we just plug in 0, so our y-intercept will be 6. Since we have an odd degree with a positive leading coefficient, our end behavior will start down but end up. So then when we graph it, let's see, I'm going to put my x-intercepts on at 2, at -3, and at 1/3. And then my y-intercept at +6. We'll just say +6 is up there. Alright, so I'm going to start down, end up. So I have to go through -3, through +6, down through 1/3, and then up through 2. Not the best looking graph, but that'll work. For number 13, we want to write a polynomial in factored form that has the given zeros with the given multiplicities. So if we're given that we have a 0 at 3, we know that the factor will be x minus 3. And since it has a multiplicity of 2, we want to square the factor. Then we have a factor at 1 with a multiplicity of 3. So that will be x minus 1, and we want to cube the factor. And then we have a factor at 0 with a multiplicity of 1. So that is just an x, because x minus 0 is just x. So I'm just going to put him out in front. And since he has a multiplicity of 1, we would just give him an exponent to the first, but we don't need to. So that would be our function. For number 14, we want to write the polynomial equation that has the zeros at 2 plus √6 and 2 minus √6. So first, we're going to put him in their factors. So we get x minus 2 plus √6 and x minus 2 minus √6. And we learned a trick in class where we can multiply the x minus 2's together. And then we can add √6 times -√6. So if we multiply x minus 2 times x minus 2 together, we'll get x squared minus 4x plus 4. And then positive √6 times -√6 is a -6. So then our final answer will be x squared minus 4x minus 2. And that would be our polynomial with those roots. For 15, we want to do long division and divide 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 by x squared plus 2x minus 3. So x squared plus 2x minus 3 is going to go on the outside, and 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2 is going to go in on the inside. So the first question I want to ask myself is, what do I need to multiply x squared by to get 2x to the 4th? And that would be a 2x squared. And now I'm going to multiply 2x squared by x squared plus 2x minus 3. Make sure we multiply each term. So I'm going to get 2x to the fourth plus 4x cubed minus 6x squared. And now we want to subtract that polynomial, so we're going to change all the signs. And we end up with 0x cubed and x squared. So we just end up with an x squared. So now we're going to drop down the 3x. And then I'm going to ask myself, what do I have to multiply x squared by to get x squared? And that's just a plus 1. And now I'm going to multiply 1 times x squared plus 2x minus 3. So we get x squared plus 2x minus 3. And I'm just going to drop down this negative 2. So I have something to subtract. Now I'm going to subtract that. So we're going to change all the signs. So it looks like I'll get a remainder of x plus 1. So then my final answer is going to be 2x squared plus 1. And then we're going to take our remainder, x plus 1, and put him over what we were originally dividing by, which was x squared plus 2x minus 3. For 16, 17, 18, and 19, we're going to just do some operations with complex numbers. So when we add two complex numbers together, all we do is combine like terms. So 15 plus 3i plus negative 5 plus 3i, we want to just add the 15 and the negative 5 together to make a 10, and then the 3i plus 3i to make a 6i. And we're done. For 17, we want to first distribute the negative and then combine like terms. So 8 minus 9 is negative 1, and negative 2i plus 6i is 4i. In number 18, we're going to multiply 7 plus I times 7 minus I. And when we multiply two complex numbers, we need to FOIL. So I'm going to do 7 times 7, which is 49. And then 7 times a negative I, which is negative 7i. I times 7, which is positive 7i. And then I times negative I, which is negative I squared. So the negative 7i and the positive 7i just cancel out. And we want to remember that I squared equals a negative 1. So we just get the answer 50. For number 19, we want to divide 3 by 2 plus 4i. And whenever we divide by a complex number, we want to multiply the top and the bottom by the conjugate, which is 2 minus 4i. So on the top, we need to distribute the 3. So we get 6 minus 12i. And then on the bottom, since we're multiplying two conjugates together, just like in 18, the middles are going to drop out. So we'll just do 2 times 2, which is 4, and then positive 4i times negative 4i, which is negative 16i squared. And again, I squared equals negative 1, so we'll get 6 minus 12i all over that negative 16. That negative 1 will turn into a positive 16, so that's just over 20. And then we can reduce our final answer, since it looks like 2 goes into everything, to 3 minus 6i all over 10. For number 1 on the graphing calculator review, we want to graph 1/3 x cubed plus 2x squared plus x minus 1 in our graphing calculator and find out the following things. So the first thing we want to find is the y-intercept. Really, you don't need the graphing calculator to find this, because you could just plug in 0 and figure out that it's negative 1. But if you wanted to find it on the graphing calculator, you would hit Second Calc, Value, and then just type in 0 for x, and you should get a -1. To find the x-intercepts, we want to do second calc and choice number 2, which is 0. And we should have 3 x-intercepts on this graph. So to find the first one, you have to make sure the spider is to the left and then hit enter. To the right, hit enter, and then hit enter one more time. And we should get the x-intercept of -5.332 if we round. And we're going to need to do that 2 more times to find the other 2 x-intercepts. I found that the other 2 were at -1.155 and 0.487. So now to find the relative extrema, we want to find the relative max and the relative min of our function. So we can see that we have a relative max right here. And so to find it, we're going to hit second calc maximum. And we just need to make sure our spider is to the left of where the maximum is, and then to the right. And we should get a max at -3.732, comma 5.797. So that guy is our max, relative max. But we do also have a relative min right here. So to find that, we're going to go to second calc, and this time choose minimum. And we're going to make sure our spider is to the left of our minimum, and then to the right. And we should get that our relative minimum is at -0.267. Oh, 268. Got to round it. Comma -1.131. That's our min. For problem 2, we want to put the function into our graphing calculator. However, we want to be careful about how we set our window, because the stock is being tracked over a 25-day period, and x represents the days. We want to set our x minimum to 0, since we're going to start on day 0, and our x maximum at 25. And then I played around with the y min and the max a little bit, and I set the y max at 50, and for sure we want to set our y max above 31.25 because that is our y-intercept. So I kind of just played around with it and got it to be 50. So now we want to know what is going to be the maximum value of the stock and what day did it occur. So we want to find the maximum of our function. And in order to do that, we're going to hit second calc and go to maximum, and then make sure the spider is first to the left and then to the right of where we think the maximum is. So you might kind of need to make a big range to make sure you get the maximum in there. And it looks like the most that our stock is going to hit is about $41. And we can round it to 82 cents. So if you put 82 cents or 81 cents, that's fine. And it looked like that happened on the 12th day, or after 12 days, because we got 12.15. So that would technically be on the 13th day, since 12 days passed by, and then the 0.5 means we're into the 13th day. So on the 13th day, our stock reached its maximum value.